Thank you. All right, we're ready. We're live. Hello, everybody. This is Robert Hodges, and I'm one of the leaders of the SF Bay Area ClickHouse Meetup. We're delighted to have you here. What we're going to do is wait a couple minutes so that everybody can get in. Let me enable my video so that you can see what I look like. Oops. Oh, you do have my video. Let's.
You just disabled it.
I just disabled it. So, yeah, it's like you really need about 4 hands to do the streaming and do a talk and try and be an MC as well. So, welcome Alexey and Alexey Milovidov. He's going to be talking about the ClickHouse Roadmap in a few minutes, and we're also going to have a talk on visualization, which is something that Dima Borovtsov and I, who both work at Altinity, have been working on quite a bit for the last few months. Before we get going, I'm going to go ahead and turn on recording. I had it paused while we were struggling, so let's go ahead and resume it. So this is the SF Bay Area ClickHouse Meetup. We're recording the meeting, so it will be available afterwards. We'll cut it into pieces and publish it on our Altinity YouTube channel, so you'll be able to get hold of it. We will also publish the slides for both talks, so you'll be able to get to them. They have a bunch of useful links and other information you might want to refer to. I think at this point, what I'd like to do is, since we had a lot of people signing up for this, so just one moment, got a question in. So for anybody who's hearing this and you're curious about how to get into Zoom, you can go to the Meetup invitation and so invitation, I will post that, and you can go to, you have to go to Eventbrite to sign up.
Maybe we can just send the public link for everyone. So people will not have to sign up.
Yeah, let me see if I can find that link. Just a second.
And we can post this link directly on YouTube so people can join. And I will post this link in our chat.
Okay, great. But I want to say that for those of you who are listening on YouTube, you can go ahead and listen. It works great. We can have questions and things like that. Oh, I see. So Bob joined with Eventbrite and didn't get the Zoom link. Well, we really better post it then. So let's go ahead and post that link right now. Just 1 second.
Send it to Zoom chat or in Telegram.
Okay, good. So we'll have a bunch of people coming in. Hey, Alexey, can you send me the link as well? Actually, I can see it on Telegram because I don't have the public link.
Most likely, the link that I have is a private link.
That's going to have everybody joining as a panelist, actually. So we're going to need to. So, all right, let's bear with us a minute here, folks. We will have you set up in just a second.
You can get this link in Zoom. Just click on participants and select invite and generate a link.
Huh, I don't see that. Yeah, I'm seeing a different, I'm seeing a different one. I don't have a way of generating that link. Can you just text it to me through Telegram?
Yeah, I will try. So this is the link. It looks unusual. I'm not sure that it is available for people who are not registered, but let's try.
Okay. Okay, we got a bunch of people who didn't get the link. I'm sending that out on all right, I see at least 3 people. Okay, that's a registration link. Let's see if people can get in on that before we get started.
I'm not sure that registration should be required. It will be better just to proceed with some public link. Maybe you can find it in the settings of this meeting.
Just a second, let me get the for folks on the call right now, did you get, it looks like most of you did get links. So we have this, let's see, make the ultimate. Wow, this is really annoying. Okay, thanks for those of you. For those of you that weren't able to get to through Eventbrite, can you try to do it again? Because I'm having trouble generating a link that is that's going to work for you. I think we may just skip. All right, so we got great for people who Bob got in. So anybody who's having trouble getting in, that link that Alexey provided is good. Let's do the following. Why don't we get going, do some intros here. I hope this will enable people to get in. So Alexey, you've also posted it out in Telegram. Let me just go ahead and post it in Slack as well, and then we can get rolling. All right. I'm just going to go ahead and post it on random. Okay. With that, what I'm going to do is go ahead. What we normally do when we start these meetings is we go ahead and let everybody just introduce themselves before we dive into the talks. So we have a number of people here. I'm going to go ahead and unmute you. And if you don't mind, if you're connected, feel free to go ahead and introduce yourself in alphabetical order. Just, you don't have to. We don't make people talk. So, and just tell us, where you're coming from and your interest in ClickHouse. So,
hello.
Hi.
I'm Eugene. I'm working for Sensor Tower. We're not using ClickHouse, but we are considering. So I'm just joined to listen about the new developments and what's available, the news.
Great.
Basically.
Welcome. So thank you so much. Somebody else want to jump in? I see an Andre M. If you want to go ahead and introduce yourself, I'm just going to call people out in alphabetical order.
Yeah, hello, sure. My name is Andrei. I'm working in Finland company. It calls Valamis, but I live in Russia. And now we are building a new reporting solution based on ClickHouse and Superset.
Wonderful. Okay, great. Because we'll be talking about Superset a little bit later in this talk. We also have Alberto. Pardon me, I skipped over you in the alphabetical order. Alberto, if you want to introduce yourself, let's go ahead and allow you to talk.
Hello, can you hear me?
Yes.
Yes. Hello. I'm only a programmer that like C++ and also discovered the ClickHouse in the last year, and I only here to learn to new things about ClickHouse and novelties.
Great, welcome. We're glad to have you, and I hope you will find this a good place to learn. It's a very good community. Let's see, next one in alphabetical order. How about Bob Morley, if you're able to unmute?
Sure. Yeah, I'm Bob. I'm just outside of Toronto, Canada. Our company's been using ClickHouse fairly limited, and I've only looked at it for a couple of months now, but we're looking to migrate from a monolith and get all of our stats into ClickHouse. So we're expanding usage.
Great, welcome. Let's see, next person, we already had Eugene Fabio Rivolera. I hope I pronounced that right. If you want to introduce yourself. Don't hear you. We'll go to Greg Jacobs.
Oh, yeah. Hi. Yeah, we're starting to look at ClickHouse to kind of augment and add to some other existing storage technologies we use for event monitoring, things like that. And we're coming from a company called Arctic Wolf.
Oh, great. Welcome. Yeah, that's I've heard of you guys. So wonderful to have you on board. Let's go to Habibullah, if you'd like to go ahead and introduce yourself.
Hi, my name is Habib. I'm a data engineer with Meetup, Nigeria, Lagos, Nigeria. So we started using ClickHouse some months ago. So we use it for running analysis on some data we generate every day. So I'm here to learn more about the software, just to get more familiar.
Wonderful. Thank you so much, and it's great to have you. I guess we're covering the continents pretty well today. Great. So next person on the list, Jason Lee.
Oh, hi, this is Jason. I'm based in the Bay Area. I'm actually in Berkeley. So our company is looking into adopting either TIDB or ClickHouse for analytical processing for the analytics team. So that's why we're here. Yeah.
Great. I hope we can help you make the right decision. Okay, John Jensen, if you want to do a quick intro.
Yeah, so I'm based in Nova Scotia in Canada on the East Coast. I've been using ClickHouse for a year or two, and I'm using it for aggregations. I'm heavy user of materialized views and things like that. So I'm doing some large scale data collection and aggregation, and it's working really well. So I'm hoping to learn some new tricks.
Great. Larry Snisek.
Hi, yeah, I work for a company called CTN77 in the Czech Republic. We've been using ClickHouse for a few years now in a HTTP logging pipeline, and recently started scaling up, running into some interesting challenges, and really learning more about ClickHouse, keeping up with the latest developments. So this is a very nice opportunity to learn more.
Excellent. Welcome. Leandro Gutierrez.
Hi everyone. We are from Argentina. We are working for a year with ClickHouse, and we are happy to say that we have some reports running on production today. So we are happy to be here.
Thank you so much, and glad you could make it. Let's see. Looking down in alphabetical order, Min Wei, if you're able to introduce yourself.
Hello, I'm Min Wei. I'm actually from the Seattle area. So I'm actually very interested in how to learn about see the superset integration with ClickHouse. I would love to see the demos.
Cool. Okay. Let's see. Going down, Sasha Velodnitsky.
Hi. Yeah, my name is Sasha Velodnitsky. I'm here in Bay Area, and I'm with NetFlow Logic. Actually, we released our next version of NetFlow Optimizer yesterday that has direct output to ClickHouse. So that's been in development for a while. looking forward to partnership.
Great, congratulations and welcome. And we've seen you many times before at previous meetups, so great to have you back. Sergey Sergeyev.
Hey, how are you guys? So my company basically uses different technologies for metrics, stores, etc. But we keep an eye on ClickHouse technologies. So we're really interested in ClickHouse.
Great, welcome. Vince Slavov, if you're... Oh, Vince, I see you unmuted, but I don't hear you. I don't know if you're having audio problems. Okay, is there, let me just say, is there anybody that we missed? Because other people were coming in. If you'd like to just step up and introduce yourself. I know John Hummel is there. I saw you come in. You should be able to, John, you should be able to talk.
Oh, hello, everyone. Yeah, this is John Hummel. I'm the technical writer for Altinity, so I'm here to take notes and learn more and hopefully keep the documents up to date so you guys can use what we're doing.
Cool. On this side, I want to introduce Denis Zhuravlev is here. I think many of you know him as Denny Crane. Denis, you want to say hi?
Hi, I'm hello. I'm Denis Zhuravlev, Denny Crane. I live in New Brunswick and in St. John, and I'm ClickHouse specialist, and I work in Altinity as a support engineer. Welcome, everybody.
Great. Okay, wonderful. So welcome. We'll have more time to ask questions and things. I'm going to leave people unmuted, although if we get background noise during the talk, I'll probably just go over and mute you, so that we don't disrupt the presentations. What I'd like to do is go ahead and dive in and just talk about a couple things that are coming up. So can everybody see my screen, the one that says SF Bay Area ClickHouse? I assume that you can see it because I can see it I can see it coming up on YouTube. So I just wanted to very quickly cover some upcoming news. And this is, I think I mentioned in this talk that we're going to have some interesting announcements, and one of them's on this page. So first, just normal business. We've already are tentatively looking at another virtual ClickHouse meetup date. So that will be at this same time on the 25th of August. And we haven't I do have one proposal for a talk there. We'd really like to get community talks here so that it's not us just like it's not us running the meetup and doing the talks. We'd like to really share stuff. So we do have one talk potentially coming from somebody who's doing NetFlow management in the UK. That's interesting. If you have a topic you want to talk about, please let me know. We'll post the invite and give you a way to contact us. You can also send email to info@altinity.com if you want to present. Another thing, since this really is the SF Bay Area meetup, we haven't had in-person meetups now for close to a year and a half due to COVID, but with everybody at least in this part of the world getting vaccinated and California opening back up, we are going to have an in-person San Francisco Bay Area meetup as soon as possible. Our friends at readme.io have kindly volunteered to use their offices. So we're looking to set something up. That'll be in the evening, and we're just trying to figure out a date, but you can look forward to that. So maybe not so much if you are coming from South America, but and then finally, speaking of worldwide, we have really excellent representation today. I'm a little bit disappointed that I'm not sure we have anybody from Asia on this call, but we do have 4 other continents represented. And one of the things we're starting to think about now is ClickHouse community is really large and it's totally international. There are hundreds of unique contributors every year that are submitting pull requests. There are literally thousands of people who have filed issues or otherwise, done things that helped either ClickHouse or the ecosystem projects around it. We think it's time to have a worldwide online conference for ClickHouse. The sort of name for planning is ClickHouse World. And so we're looking right now for people who are interested in participating in this and would like to help us set it up. So if this is something where your company has, organizes, has organized this kind of thing, or you just like to pitch in and help, please let us know. You can either contact me or Alexey Milovidov. We are sort of in the planning stages and just kind of trying to put together a team that can make this conference really happen. So you'll hear more about it, but just in a nutshell, the idea is to do a Zoom-based conference, well, presumably Zoom, but 24 hours of talks spanning the globe. We also may have, if we can manage it, we'll have a second track that does tutorials. In fact, we'll do as many tracks as we think we can handle, but the idea is to allow everybody from this worldwide community come together, share what they're doing with ClickHouse, and meet other people from the rest of the community, even though we can't all travel to see each other in person. If this is successful, we hope that in 2022, we'll be able to follow on with perhaps even an in-person conference that begins to gather together the ClickHouse community from all parts of the globe. So I very much hope that this sounds like something you're interested in participating again in. If you're not able to help, don't worry, we'll publicize it. But if you do have interest in working on this, let me know. This is going to be community driven. It is not going to be a vendor conference. We're not going to have, a bunch of people trying to sell stuff. It's just the ClickHouse community getting together and sharing. So unless there are any questions about the upcoming events or the form of this, what I'd like to do now is go ahead and turn this over to our first speaker, and that's Alexey Milovidov, who is the lead committer for ClickHouse. He's also the original designer, and it's my pleasure to introduce Alexey and turn it over to him to talk about the ClickHouse roadmap.
Okay. By the way, Robert, you did not cover the birthday.
I didn't cover what?
The birthday. That was yesterday.
Oh, no, I didn't. That's my apologies.
Don't worry.
Yeah. All right, here, let me kill my share so that you can, just a second.
Okay, so just remember the date, June 15. 5 years ago, we decided to make ClickHouse open source. And we made it exactly 5 years and 1 day ago. So if you did not celebrate it yet, it is the perfect time to start.
Yeah, happy birthday, ClickHouse. Thank you, Alexey. And yeah, thank you for open sourcing. I don't know if everybody on this call knows this, but Alexey was the major driver, as far as I understand, to get this thing out into Apache 2.0, which has then created this huge community. So Alexey, take it away.
Okay, so my presentation is about new ClickHouse features. But if I will have to present all of the ClickHouse features for the past half of year, I will spend probably 3 hours or 5 hours, but I will try to select some of the most favorite, and I will try to pack everything in just half an hour. So let's start. One of the most frequent questions about ClickHouse SQL dialect that I receive is, does ClickHouse support window functions? Recently, the answer was no, but now it is yes. ClickHouse does support window functions. Let's look in more details. First, I want to say that ClickHouse does it in full correspondence to the SQL standard. No surprises. If you have worked with window functions in PostgreSQL or MySQL 8, you will be familiar and you will be able to use the same syntax in ClickHouse. This feature is completely supported since version 21.4, but it still requires experimental flag. You may check it, you may use it in production. Maybe you will find some minor details in implementation. Just report to us and we will implement the remaining details. So basically everything is supported. Over partition by and order by clause is supported. All aggregate functions can be applied over windows. Windows can be defined in section after section from. You can use whatever specifications for window frames like rows, unbounded, preceding, or something like that. And we support multiple non-aggregate functions that works specifically for window as window functions like rank, dense rank, row number, and whatever. So what is the next? In ClickHouse, we have integrations with multiple external data sources. For example, you can use table functions to connect to MySQL. But now it is also available for PostgreSQL. Recently, you still being able to connect to PostgreSQL, but you had to use ODBC table function, and ODBC interface is just not the best way to interact with PostgreSQL, especially if you compare with native protocol, native library. Now you can use PostgreSQL table function, PostgreSQL table engine to interact with PostgreSQL directly. It is available both for reading data with select and writing data back to Postgres for export with insert. For example, you can join a table from PostgreSQL with ClickHouse table, or you can just use ClickHouse to join two different tables in PostgreSQL. You can also create a database with PostgreSQL engine. It will magically represent all the tables in PostgreSQL schema in remote server. You can use PostgreSQL as dictionary source. And finally, you can enable PostgreSQL protocol inside ClickHouse. If you do it, ClickHouse will pretend to be PostgreSQL. You just connect to some specific port with PSQL client or some other clients for PostgreSQL. And you will get the same interface as PostgreSQL, but ClickHouse will process and answer the queries. Obviously, you will see the difference in query processing speed. But you still have to write queries in ClickHouse dialect. So what do we have? It is mostly like MySQL integration, but for PostgreSQL. You can also specify shards and replicas inside the address. So you can create, you can use ClickHouse to implement distributed queries over multiple instances of PostgreSQL. In this example, I just specified 3 replicas for failover. ClickHouse will try to connect to one replica if it's unavailable to another replica. But if I replace the pipe character to the comma character here, it will treat multiple servers as shards. And it will connect to multiple shards, query the data, and merge this data inside ClickHouse. So ClickHouse can be also implemented as a sharding solution for PostgreSQL. And also now we have PostgreSQL style cast operator. For example, if you write this expression cast 1/10 as decimal, it looks like just fine, but actually it isn't, because 0.10 is a floating point number. It is a floating point literal in SQL. And if you use decimal data type with more precision, you will see that some digits are just off, because there is no machine representable floating point number equals to 0.1. To fix this issue, you can just type 0.0.1 as a string. It will parse it correctly without conversion to floating point number. It will parse it directly as decimal, and the result will be just fine. But now you can also write PostgreSQL cast operator that looks like just two colons. It will work exactly as if you write this in a string. It is already available since version 21.6. And as a bonus, if you write this operator for arrays, arrays will be parsed and processed more efficiently. So this is for the case when you have an array with millions different numbers in your query. You may think that it is not typical case, but for some users it is typical. They have queries for megabytes of SQL. So now we have native integration with PostgreSQL, and I can say that ClickHouse loves PostgreSQL. ClickHouse also loves MySQL, and it loves MySQL equally well. And ClickHouse is actually a very friendly system, because we are trying hard to love also HDFS, S3, ODBC, JDBC, MongoDB, Redis, Cassandra, Arrow, gRPC, Kafka, RabbitMQ, whatever. Some of these integrations probably requires and deserves more love. And we are ready to spread the love to all these systems. So what about integration with some programming languages? If you want to use ClickHouse, you can always use its HTTP protocol that is very simple. It allows to represent ClickHouse as a REST service. Just send your query, receive your result in arbitrary format. But HTTP protocol does not support bidirectional interaction like query cancellation, receiving the progress for query. To make this interaction, you can also use native protocol that is used by ClickHouse client and also by some selected drivers for some programming languages. But native protocol is not standard. By the way, gRPC is also not standard. It is just some protocol for some G-word company. But it is quite popular. So now we also implemented support for gRPC in ClickHouse. Just uncomment to enable gRPC port in configuration file. And you will be able to implement your clients with query cancellation and query progress. We have prepared an example. It is located in our source code. It looks like my favorite ClickHouse client, but it is implemented in Python and it is using gRPC. So whatever language do you use, even Go or Rust or Elixir, you probably will be happy to spend some time implementing gRPC client for ClickHouse. So what is the next? The next is the range for date time data type. In ClickHouse, we have 3 data types for dates and times. First is named date. It is to store calendar dates, just that looks like year, month, date, but actually represented by the number of days since Unix epoch, since year 1970, January 1st. Another date type is date time. It is represented by Unix timestamp. Unix timestamp is the number of seconds since year 1970 in UTC. And recently, the range of supported years was just from 1970 to year 2106. But it is not enough for every application. For example, what if you want to store the birthday of your grandfather in ClickHouse? So your grandfather will come to you and ask, could you please just record the date of my birthday? And you will say, no, we have support only for dates since year 1970. This is just not good. We decided to extend this range, and the extended range is supported in date time 64 data type. Now the range is from 1925 to 2283. So maybe you will be able to store the birthday of your grandfather, but it still depends. It still depends. But you definitely will be able to store the maturity date of your mortgage loan. And I calculated it is just 222 years for free. And we have implemented it with absolutely zero performance drawbacks. It works just as fast as before. And I can say definitely my grandchildren will use ClickHouse. And maybe they will write ClickHouse also. So what is the next? What is next? Suppose you want to parse HTML. HTML parsing is a very dreadful task. It is very complicated to do. There are multiple standards of HTML. Do you remember XHTML, for example? And suppose for some very strange reason, you want to do it inside ClickHouse. What is the reason? ClickHouse is such a good system, and you just want to do everything inside ClickHouse. Why not? So now we have a function named extract text from. it will allow to extract text from HTML, and it does it in 20 gigabytes per second. I'm not sure that anyone else can parse HTML in 20 gigabytes per second. But in ClickHouse, we have to break the records. So now we have this feature for you. What about integration of ClickHouse in some infrastructure with microservices? So probably you like microservices. And ClickHouse is not a microservice, it is mega service. But maybe you have integrated ClickHouse in some service mesh. And you want to monitor your entire infrastructure, every request that will use ClickHouse. To do this task, we have implemented support for OpenTelemetry. It is enabled by default. You will just have to send HTTP headers for OpenTelemetry. Data will be stored in system table. And if you check the documentation, you will see how to export this data to Zipkin. Zipkin or Jaeger. ClickHouse is already annotated, so you will see what is happening inside your query. It is available since version 20.11 since November. What about import and export? In ClickHouse, you can import and export data in a wide variety of formats, like tab separated, comma separated, whatever separated, Parquet, protobuf, native format, arrow. Don't mix up arrow and arrow. They are different formats, and both are supported inside ClickHouse. And also we have transparent support for import and export of compressed files. You just specify a file with some extensions like GZ, Brotli, and now we also have support for XZ or LZMA and ZSTD. And you can import this data with URL engine or with ClickHouse client or with S3 table engine or with file table engine. So whatever way you use to import or export your data, it will support transparent compression and decompression. If you ask me what is my favorite, GZ, Brotli, XZ, or ZSTD, I definitely say that my favorite is ZSTD. What else? Now we have map data type. So ClickHouse is mostly used for structured data, well-structured data. But sometimes people ask me, I have some data, but actually I don't know what my data is. What are the data types? What are the columns in my data? I just have some data, and I don't know what it is really. And usually I suggest just to spend some time and to figure out what is the structure of this data. For example, if you have log data, logs, you definitely have a column with date and time. Probably you also have a column with host name, but the rest can be nested JSON with additional attributes. And what to do if you don't really know what are these additional attributes? You can just dump all of them into a field with type string. But it will be just more optimal and more manageable to store it as a map, like key value map, from attribute name to some value. And you will be able to use familiar and quite intuitive syntax to query this data. It is just more convenient to use. So what if you have key value dictionaries? Key value dictionaries in some other data sources. If you have external key value dictionaries, you can attach them into ClickHouse as external dictionary. You can attach external dictionary from MySQL, from PostgreSQL. You can use whatever HTTP service or S3. But sometimes you may want to store your dictionaries locally inside ClickHouse. But ClickHouse is not really well suited for key value requests. So we have created table engine named Embedded RocksDB that is specifically designed to serve key value requests inside ClickHouse. And the best application is to use this table engine as a dictionary source. So what about SQL dialect inside ClickHouse? I can say that ClickHouse has not 100% coverage of SQL standard. But in many senses, SQL in ClickHouse is just better. It is more convenient to use. It has multiple extensions designed for specific practical needs. But we have intention to also cover the SQL standard. And for this reason, we approach to make better compatibility. So now we have implemented multiple missing features like union distinct, replace table, and create or replace tables. We have common table expressions inside ClickHouse. We have multiple additional syntax sugar, like position needle in haystack. Recently, you just have to write position, haystack, comma, needle. But now you can do it in SQL way. So the next is quite more complicated to explain. Semi-duplicate text search. So is it possible to apply ClickHouse for text search? Sometimes there are stories when people just replaced Elasticsearch to ClickHouse. But in these scenarios, in most cases, people just used Elasticsearch without any sophisticated text search features. So just for log analysis and for simple substring searches inside logs. And ClickHouse is actually well suited for this task. It can do this task, especially heavy filtering, heavy aggregation of data, heavy analytics, much better than Elasticsearch. But what about real text search with some analysis of texts like normalization, lemmatization, whatever? I will explain for just one application, semi-duplicate text search. For example, you have an article, a document, and you have similar document with a few edits. And you want to search a large corpus of some documents to find similar documents. How to do it? We have implemented min hash and sim hash algorithms. I will try to explain min hash algorithm with some hand waving. So how it is working? Get the text and extract every single from this text of n consecutive words. For example, in this text, every single of 3 words will be extract every n, extract n word single, and whatever. Step number 2, calculate hashes of every this single. We will transform the text to a set of hashes. Step number 3, select some number of hashes with minimum value of hash, and the same number of hashes with maximum value of hash. For example, we will select this single because it has the hash value closest to 0. So now we have some set of minimum hashes and some set of maximum hashes. Step number 4, calculate hashes of hashes. Just hash these sets of hashes into 2 total hashes. Do you follow? Probably not, but I will have to explain it. How the algorithm actually works. When we have 2 numbers, just 2 numbers, we consider that texts are duplicate if at least one of this number is equal for different texts. Basically, this algorithm is an example of locality sensitive hashing. So when some text changes a little, the hashes either do not change at all or just one of 2 hashes will change and another remains. Okay, not the most simple feature in ClickHouse, but it is real data science. What is even more difficult to explain? Statistical tests. If you are into data analytics, probably you're already familiar with the notion of t-test. If not, I will try to explain. Suppose you have several measurements, for example, measurements of performance of your website or your web application, and you want to make an experiment. You change something on your website or in your application. For example, change the color of the button from green to red. And you want to measure the difference of performance. So you have different samples. A sample of data with experiment and without the experiment, with a red button and with a blue button, for example. How to compare these samples? You may just calculate the average, compare the averages, but how to be confident that one sample is actually gathered from a distribution with a different average. For this reason, for this purpose, there are different statistical tests, like student t-test, Welch t-test, Mann-Whitney U-test. The difference is quite subtle, and you have to actually learn some statistics to figure out what test you actually need to apply. Some tests can work under assumption that distributions have equal variance. Some tests did not make this assumption. Some tests assume the normality of distribution. Some tests are parametric and some are not. But if you are into mathematical statistics, you just choose whatever test that you need, and it is already implemented in ClickHouse. Just run it as aggregate function, and the task is done. As a bonus, we also implemented rank correlation function. So the correlation, if you don't care about the exact values of measurements, but you do care about their relation to each other. And we are going to also add Kramer's V and Tails U. Don't worry, I will not even try to explain what is it. Let's go ahead. And this is probably much more appreciated than previous. Support for projections inside ClickHouse. So what is projection? Projection allow you to store multiple data representations inside a single table. You can have data in multiple different orderings. Because sometimes you have to think very carefully on how to choose the order by key for your table. If you choose the correct order by key, one queries will work faster, other queries will rely to full scan in the worst case. But sometimes you cannot just choose the single right ordering, the single best ordering for your data. One example is banking transactions. You have a log of banking transactions, and you have two columns. One column with the date and time when a transaction was initiated, and another with the date and time when transaction was processed. And you want to filter data by one column with date and time or another. So you cannot just choose single ordering. But with projection, you can create projections that will store the same data with different ordering. And when you just do your query, ClickHouse will automatically select the best projection, the best representation of data to process your query faster. projection can store subset of columns, or even projection can be aggregated. You can create projection with group by, and it will do incremental data aggregation for you. The only question that you may have is how it is different to materialized views. And I can answer that materialized view is a separate table that is updated as a trigger on insert. The data in materialized view is not necessarily always consistent with the main table. But with projections, atomicity of insert and consistency is guaranteed. When you insert the data into your table, or when you drop partition, projections will also be updated as well. They are guaranteed to be always consistent. And the second, also important, is that projections are automatically used in select queries. You don't have to query materialized view explicitly, just query your table, and queries will be processed magically faster.
Hey, Alexey, could I ask a very quick question on projections?
Okay, go ahead.
You say that you note the things that are different, but I noticed that partition key is not one of them. So is the idea that, excuse me, is the idea that the parts, you have the same set of parts, but they're, you know, like, so an individual part can be like sorted and with different columns. And so what you're saying is basically you're going to merge them at the same time. So if you're doing a background merge on the part, you'll then update all the projections of that part. Is that how it works?
Yes, absolutely. This is correct. The partition key is shared among all the projections. The set of data parts is also shared. Data parts are merged together with data for all partitions.
Thank you. And I just posted a link both here and on YouTube for Amos Bird's talk. It was really good.
Okay.
Thank you.
I can say that you actually know ClickHouse internals really well, especially this new features.
It's easier than YouTube streaming.
Okay.
Thank you.
So what is next? The next will be interested only for clients with huge clusters. Not many people that use ClickHouse have clusters with hundreds or even thousands of servers. But there are these clients. And ClickHouse is actually very scalable. It is designed to be scalable across multiple geographical regions and to cluster sizes of multiple thousands of servers with hundreds petabytes of data. In Yandex, the largest cluster is just 600 servers. But in some Chinese companies, there are clusters with more thousands of servers. On large cluster, one of the problems is tail latency. So ClickHouse has support for failover. If some replica is unavailable, ClickHouse will transparently distribute load to another replica. But it is not always the case that replica can be available, just available for requests, or just unavailable. It can also be barely available, but answer very slowly. And it will introduce what is named tail latency. So you query ClickHouse through some distributed table, and this distributed table will send your query to 1,000 of nodes. And if just a single node will answer slowly, all your query will also be slow. And actually, I hate slow queries. ClickHouse have to work always quickly. It must work quickly. So we have to address this concern. And now we have support for hedged requests. What is it? If we send a query to some replica and it is starting to answering slowly, just not answering within some timeout, we can successfully connect to this replica, but it either does not send the progress to our query. We will speculatively send the same query to another replica, and we will wait for the answer of both of them. And we will just select whatever replica that will answer more quickly. And your queries will work fine and quickly, even on huge clusters with thousands of nodes. This is already available and enabled by default. So what about, this is already implemented, and what about the next features? The upcoming features. By the way, we are completely open. Our roadmap is publicly available. You can read it, you can comment, you can even suggest something new. I will not read you the whole roadmap. I will just do some highlights and examples. Something the most appreciated, the most favorite. So we have plenty of tasks. And let's look at the first. Provide alternative for Zookeeper. If you follow me, maybe you are already excited. So yes, we will get rid of Zookeeper. We will do something better, something more easy to use, more easy to operate. But let me first explain something even more exciting. Support for nested and semi-structured data. I already told you a little about map data type, but I want also to present something even more interesting. The object data type. I will just object on this object data type, what it is about. Suppose you have a data set that is represented by some deeply nested JSON. You have some well-defined fields like ID, but also not well-defined fields like data that consists of some fields that you don't even have a time to describe. And you want to store this data inside ClickHouse. And you want to do it in ClickHouse way. So you want to do it efficiently with data stored by columns, processed by columns, as fast as if the data types and columns will be explicitly specified. And now we have a prototype that supports for this feature. It will just analyze the data dynamically. It will extract every path in JSON like K1 or K2.K3, every path in JSON will be stored as a separate column. If some columns are not always presented, we will use some sparse data format to save the space and process data efficiently. And we provide a syntax very natural that allows you to query nested data with expressions like here. Data.k2.every field, it will be extracted as a tuple, named tuple of fields. About data types, we will automatically analyze data to figure out the most efficient data types to store this data. For example, it can be integer or string. For integer, we will automatically choose the smallest representation, the most compact representation. When we merge data parts together, data types will be automatically merged to the common data type. And you can specify data type explicitly, like here. I want to extract the field K2.K4 with the data type string. If it is already stored as a string, it will be essentially free. If it is stored in different data type, conversion will be applied at runtime. So, what is all about? It is about to store semi-structured data as efficiently as structured data and processing it as efficiently as structured data. So your dream to replace your favorite MongoDB with ClickHouse maybe will come true. It depends on how do you use MongoDB. If you try to use MongoDB for analytics, probably you don't even have to wait for this feature, just replace it with ClickHouse and you will see tremendous improvements in query processing speed. Next is about how to make ClickHouse even faster. So you know that ClickHouse is fast. When ClickHouse is processing your queries, at the first time, you usually don't believe that it is even possible. That it is even possible to process your queries so quickly. But when I see that query is processing in, say, 10 milliseconds, first time I think that 10 milliseconds probably it is fast. But a millisecond later, I will just do a grumpy face and ask myself, why 10 milliseconds? What we actually doing all this time? Why not 5 milliseconds? What if I will be able to optimize this query? What if I will be able to optimize ClickHouse source code and shave off 5 milliseconds? If my query is processing in 5 milliseconds, then I will be again not quite satisfied, because I will ask myself, why 5 milliseconds? Why not 4 milliseconds? I want to just win this 1 millisecond, if I can. And me and my team are constantly searching for any ways how to make query processing even faster. There are just two ways to make it. First, vectorized query execution. And second, runtime code generation. And I can say that we just do both. We do whatever way to be better. But most of the performance comes from vectorized query execution. And just-in-time code generation, it is also implemented, but it was disabled by default due to some difficulties, some possible incompatibilities in corner cases. It was disabled by default, but now we have made some efforts, and now it is available since version 21.6. It is the most recent stable version of ClickHouse, released just in June. Let's try it on one synthetic query. We will try to calculate hash function murmur hash inside ClickHouse. Actually, we already have the function in SQL directly for this task. It is named murmur hash, and it works quite quickly. But what if we will try to pretend that it is not already available and just write it by hand? You don't have to do it in your production, but probably sometimes your queries will be somewhat similar. And let's compare the performance. Without just-in-time compilation, it was 34, almost 35 gigabytes per second. You can say it is already fast, but if you don't see that after we enable just-in-time compilation, it will be 87 gigabytes per second. 87 gigabytes per second. It is ridiculously fast. I don't know how to say, but probably it is literally impossible to make it even single gigabyte per second faster. So we have this 2.5 times performance improvement on specific synthetic query. In your real queries, probably you will have a few percent, but just for free. And now, the most interesting, the alternative to Zookeeper. So what is Zookeeper? Distributed coordination service. Zookeeper has some advantages. And the main advantage of Zookeeper is it works. It works correctly. It actually does the stuff. And we use Zookeeper for distributed coordination. But when you install Zookeeper, you may see the difference between ClickHouse technology and Zookeeper. For ClickHouse, you can see that ClickHouse is so convenient. It is installed with a single binary. It runs out of the box. It does not require any significant configuration. You just install, if you want to install on cluster, you just install on cluster. But now you also have to install Zookeeper. Zookeeper is some Java application from another world. Some people don't like Java. I don't know for what reason. But at least you have to configure some parameters like JVM heap and you may find it inconvenient. You may also find inconvenient that you have to use some third-party servers in addition to ClickHouse. What if coordination service will be just built in to ClickHouse itself? And we are going to implement exactly this to replace Zookeeper. It will act as a drop-in replacement. It is already supports Zookeeper network protocol. It is already we already support abstraction that allows to replace Zookeeper to different services. But this abstraction is actually unneeded because we can talk to this service with Zookeeper protocol. We have implemented Zookeeper data model. We have implemented the server that act like Zookeeper. We have implemented Jepsen tests. We run Jepsen tests continuously in our continuous integration. Actually, we have implemented more sophisticated tests that has been implemented to Zookeeper itself. We have found some deficiencies in Jepsen tests for Zookeeper, and we have improved these tests. Now we also implemented support for reading Zookeeper snapshots and logs. So you can install this service. By the way, it is named ClickHouse Keeper. A cute name, by the way, cute. And it will work just as Zookeeper, but better. It will use less amount of memory. You can use it with less operational complexity. And in the meantime, we have also fixed some bugs, or maybe some bugs that are just cannot be fixed if we use Zookeeper, like ZXID overflow. If you are not familiar with what ZXID overflow is, you are just happy user. But users with higher loads tend to face this issue. The snapshots will be compressed. If we compare the size of snapshot, for Zookeeper, it is 12 gigabyte from some of our clusters. And for ClickHouse Keeper, it is just 1 gigabyte. No magic, we just write compressed snapshots.
Hey, Alexey.
Okay.
I want to just do a time check here because we've got another talk that's going to run about 30 minutes and we need to get done by the top of the hour. Is that
how much? 5 minutes, maybe 7. And we will go straight to the next talk or to the questions.
Is this a good breaking point for you, or were there other major things that you wanted to touch on?
No, it is not a good time to break. I will continue because I have so many exciting features to tell.
Okay, so we'll run the visualization talk right after this. So we'll probably just truncate the questions a bit. Thank you.
Okay, so the next is about short circuit evaluation. Suppose you write this query just to calculate remainder of division of some number. Sometimes number is 0, and you know from your school you cannot divide to 0. And you will get an exception if you divide to 0. But you are smart, you know that you cannot divide to 0, you just write it inside if. If number is 0, just return 0. If not, just divide. But surprisingly, you will still get an error division by 0. Because ClickHouse will calculate both sides of the if both branches, and in calculation it will try to divide to 0. You can also write it in where section with AND operator. You may think, if left-hand side of AND is false, probably there is no sense to calculate the right-hand side. But ClickHouse will calculate the both sides, and you will still get an exception division by 0. You might try hard and hide it into subquery. Just write a subquery, filter data when number does not equal to 0, and then divide by number. But it does not help. You still get division by 0, because query is optimized. The expression will be pushed down into subquery, like here, and both sides of branches will be calculated. So how to avoid this issue? What to do? The answer was that it was actually impossible. But now we have support for short circuit evaluation, and it does exactly what you want. When you calculate this expression, first left-hand side will be calculated, and the right-hand side will be calculated only when left-hand side is not false. Next is about user-defined functions. We have designed 5 different ways to implement user-defined functions, and selected just 2 of them for the first time to implement. First is user-defined functions as lambda functions. You just write create function as expression. You can use this function inside your queries. Expression will be substituted and evaluated. And the second is executable script like shell script or Python script or PHP script or Perl script. It depends on your choices. And ClickHouse will just pipe data into this script and receive the results of the function. And you can just write this function inside your query. Next is about replicated databases. So when you want your table to be replicated, what to do? You have to create one replica, another replica, another replica, and this for every table. Now we implemented a database engine named Replicated. This database engine will automatically replicate all data definition queries across all replicas. Just do create table query. It will be automatically replicated. Distributed processing of external data. So if you have a cluster of computational nodes that run, every node runs ClickHouse, and you have external data on S3, you can use all available computational resources to query data and process data from S3 in distributed fashion. So you have your data in a cloud, and you have a cluster of, say, 10 ClickHouse instances. And you will be able to use compute power of all 10 instances to process this data from the cloud. The next will be merge tree table engine on top of external storage. And probably the last but not least, it's a small feature, but it is very neat. So it is about XML. XML is probably a boring technology from the ages of Java. I have nothing against XML. It works. It has a standard. It is wide used. But I heard that people don't like XML for whatever reason. XML is not fashionable. What is fashionable? JSON, YAML, TOML. We just considered every fashionable choice and we have chosen to support YAML. Just compare. This is YAML. If you write the same in XML, probably it will not fit in the slide. And don't worry, this is just an example. YAML, in contrast to JSON, has support for comments. This is one of the most important arguments to choose YAML over JSON. So enjoy, and since version 21.7 that will be available in July, you can rewrite all your configuration files in YAML. We even provide examples for you. Okay, now maybe we have 1 minute for a couple of questions, or proceed straight to the next talk.
Actually, I promised Timur Solodnikov that we would get to his question from YouTube. It's RocksDB in ClickHouse, is it transactional?
When you insert data into RocksDB, every insert will be processed as a transaction inside RocksDB. So yes, it is transactional, but if I remember correctly, we don't use the settings to actually force data into hard disk media. So maybe you will have some caveats, but at least it will be in file system. It will be inserted atomically.
RocksDB will not support replication, I assume?
Yes, RocksDB is for specific use cases. It is not replicated. You please don't think that RocksDB can replace your merge tree tables. It is just for key value dictionaries. And for heavy analytics, merge tree, just use merge tree and replicated merge tree tables.
One final question that was up in the question and answer. What release do you think the Zookeeper replacement, I mean, you can use it right now, like in 21.6, but do you have like a target release for when you think this is going to be really ready for production use?
So if you use 21.6, you can try ClickHouse Keeper, but I recommend you to do it if you are actually ClickHouse contributor or ClickHouse developer. It is still in development. It is not ready for production usage. We will make it ready very gradually. So first we will test on our internal testing environment for a few services inside Yandex. If it will work without any issues, or after these issues will be fixed, we will try on production on some clients that will be ready to opt in to this feature in our cloud. When we will collect some issues or obstacles or some difficulties, and after we will fix these difficulties that will definitely arise, Only then we will be able to say that it is production ready. My expectation is autumn this year, not earlier.
Okay. What we're going to do now is we have a couple more questions. Alexey, if you can see them in the Q&A, feel free to answer them in the background. I'd like to dive into the second talk, which for those of you who are still watching is kind of the complement to this. We're going to go ahead and talk about visualization tools, so things outside of ClickHouse, but there's a bunch of new stuff there as well. So the talk is called Seeing is Believing, and it's we're going to talk about 3 popular BI tools for ClickHouse. So my name again is Robert, and I'll be have my colleague Dima Borovtsov. We both work at Altinity, and we're going to present this for you. So I hope you'll find it interesting. So just a little bit about us. I think as other people, you know, if you've been here before, I've been working on databases for a really long time, and ClickHouse is database number 20. Dima, who is working with us, also has a long history on this, a lot of work on database and applications, so 25 years plus, and he's been a ClickHouse user since 2017. There's a little bit of context in this, which is that we do this work as part of helping people build applications that use ClickHouse and deliver very fast analytics to users. So visualization is, there's always 2 extra parts when you consider building an analytic application. One is getting the data in, that's ingest, principally through mechanisms like Kafka S3, and then of course this plethora of things that other things that ClickHouse can talk to, and then there's visualization, which is showing the data. So this has been an area of interest for us. It's something where we've you know, made a lot of efforts to make things better for ClickHouse users in general. So that's the background. I'm going to turn this over to Dima. I'll run the slides, but we're going to talk first about Tableau. And I just want to preface this with a comment that when we used to do talks on visualization, we would either have Tableau at the end or we wouldn't talk about it at all. So, and the reason was it didn't work very well. And I'm happy to say that Dima is going to show you something that we've been working on, which should make, if you're a Tableau user, should now enable you to use it safely and get a lot more value out of your ClickHouse data. So with that, Dima, I'm going to go ahead and let you run the presentation. I'll advance the slides for you. Just let me know when you want to move.
Thank you, Robert, for introduction. So my name is Dima. I joined to Altinity as implementation engineer about 1 year ago. I'm helping our customer to implement the ClickHouse in their projects. And recently I was working on this Tableau connector for the ClickHouse. I'm not Tableau sales representative, neither the Tableau certified developer. I'm just a guy who loves to asking questions when he sees the data. And like this is a primary reason why I love Tableau. And like this is my tools to use when I have the questions like why, if I see some kind of data. Actually, today morning when I work on the presentation, I realized that my first experience with Tableau was maybe 10 years ago when I worked for one of the projects for the big telecom company as a database developer, and also I played the data analyst role, and I constantly asking for a question why, and for me it was too long to wait until I write the SQL query, write the database report to get the answer on my questions why. And there I were looking for a tool that could help me to quickly get the responses on my questions. And this was a moment in time when I met the Tableau, and I fall in love with this tool, and I still use it from time to time for my own purposes. And maybe about 6 months ago, I also again had the questions why. I tried to analyze some of the data for our client, from financial industry, and I tried to use Tableau with a ClickHouse and realized that since you have a DBC driver and the Tableau supports the ODBC protocol, it actually doesn't work very well. So you can connect, you could do the very simple things, but in general, like it's not a real working solution. So this is the reason why I started to look around to find a way how we could improve the situation with the Tableau and the ClickHouse. Couple words about the Tableau. So I consider Tableau is mostly like an exploration data tool, not the reporting tool or BI tool. Because of the Tableau has very simple drag and drop UI, it could quickly generate the queries to the database, provide you response to your questions almost in the real time. So for me and for my tasks, usually it's the most important things. And it doesn't require any like programming skills. Even the people who has no idea like what the programming is could start to work with Tableau almost immediately. It supports a huge number of different data sources. It's already more than 80. Plus, it's extendable via ODBC and JDBC drivers. And recently, the Tableau introduced SDK to add additional data sources support to the Tableau. Also, one of the like killer feature, Tableau's killer feature that almost doesn't exist in our other BI tools, its ability to join and blend data from the different data sources and show them in the same dashboard. So let's say you could extract some data from the ClickHouse, some data from the Postgres, something maybe from your local Excel spreadsheet files, bring them all together, mix and show on the dashboard. And right now already it's already like full Tableau has full ecosystem. So it has a server that could be used to publish your dashboards and workbook that could be used by everybody in your company. They have cloud service, they have reader application, mobile application, and recently they introduced new product, data prep, that is used to clean the data before analyzing this data in Tableau dashboards. Robert, can you move to the next slide? Thank you. So how the Tableau communicates with different data sources? By default, it comes with native drivers for maybe 40 or 50 different data sources. And the policy, Tableau has policy, they don't add additional drivers to the different databases by their own. They said, okay, the vendor should create this driver, send it to us, and then we try to include this driver into our package. And it's very like painful and complex process. And they introduced a DBC support of the DBC protocol many years ago. It's improved a little bit situation with support of different databases that was not supported by Tableau. But problem with ODBC that it's very common and abstract standards that should work for every database. And when you try to use the ODBC, the Tableau cannot properly use all the features and the syntax that is supported by your database because like the ODBC interface is very abstract. So we have like ODBC driver for the ClickHouse. It could be used together with Tableau. And when you try to connect from Tableau via regular plain ODBC driver, most of the features, Tableau features will not work, or syntax of the query that Tableau will generate will not be compatible with the ClickHouse. And maybe a year and a half ago, the Tableau introduced a new SDK that could help other external companies to provide better compatibility Tableau with their own data sources. So how does it work? Under the hood, the Tableau desktop or server to visualize some data, generate some kind of very similar to select query to the underlying data set to transform this query to the measures and dimensions that you want to present on your diagram. It's an internal query, it's an internal language inside the Tableau. And the driver that comes together with Tableau, it's just maybe like some kind of proxy or transformation lever that will be able to generate the query that is supported by your database. And the SDK that Tableau introduced some time ago help you to clearly define to the Tableau via the set of the configuration files, what are the features supported by your database and what is the proper syntax to use those features. So on this diagram, you could see that Tableau could connect directly to ClickHouse via a DBC driver, or if you try to install the connector inside the Tableau, Tableau will communicate with this connector and receive the information about like what are the features supported by the ClickHouse, what is the right syntax, and then it will be able to generate the proper select statement and send the statement to the ClickHouse through the ODBC driver. So the connector is just like additional configuration level layer for the ODBC driver. So it's not the code that could be running on your machine. It's just set of the config files. Robert, can you move to the next slide? So we opened this connector today for the public use. It's available on the GitHub. The connector works both in desktop and server versions of the Tableau. It requires to have a DBC driver installed. It helps Tableau to utilize all the syntax and features that already available in the ClickHouse. It's open source. It's very easy to install. Right now, at this moment, the connector is not published into Tableau Gallery because it's a little bit longer process. It will require to pass some certification on the Tableau side. We already started this process, and I expect that sometimes in the future, maybe months from now, the connector will be available in Tableau Gallery. And the installation could be done directly from the Tableau itself. But at this moment, it could be installed using the developer mode. And we have a documentation in a repository and also on our docs site how to install this connector with a screenshot and examples. And yeah, you could try to download it very quickly, even like today, and try to use it on your own with your project. And I will try to do the quick demo to show how it looks like. Let me share my screen. Okay, the first thing that I want to mention again, that with a connector, you don't need to create ODBC DSM. So you have to have like drivers installed. Right now, I have already installed the latest ODBC drivers. But to use the ClickHouse with a connector, you don't need to create a DSM. It's a like additional level that simplifies usage of our connector for the users. So let's start Tableau. I already have this connector installed. And first thing, you will see the ClickHouse in the list of the supported data sources. When you choose to connect to the data source, usually it will show the dialog window that is pretty standard, but for the Tableau, but it could be configured inside the Tableau connector. So if your database will require like additional fields, it's also could be configured inside the connector. So we just need to provide the host, port, database, login, password as usual. I will try to use the simple query to see that connection was successful. Okay, we are connected. And in our public data set, in our Altinity Cloud platform, we have a database with several open data set. Let's try to do something. So a couple years ago, I lived in New York City, and I decided to, for the demo, try to use the trip data table. It's a data about the trips using the New York City taxis. So it's a simple table that every record of in this table, it's a one trip inside the taxi. It has basic information about when the trip was started, when the trip was ended, where, what was the fare, total amount, trip duration, and the payment type. So the Tableau, again, it's very simple to use visualization tool. You just need to drag your table into a list of the tables inside your data source, and immediately you could start to do like kind of exploration of your data. And let's try to check some interesting data. I do remember when I first moved to the New York City in 2014, one of the first impressions was like when I saw in the news that license for the taxi drivers cost between the $500,000 and $1 million records, $1 million. And my first question was, well, it's interesting what will happen when the Uber will come into the city and start to do the trips. People start to use Uber for trips. So let's try to see what happened with the New York taxi after Uber arrived to the New York City. So we could try to analyze the number of trips. It's a first simple thing that we could do. We could take the date of the trip, convert to the day. Then we could try to count the day is not very good. Let's use a week number. So here we could see how the trip number was changed during the last 7 or 8 years. And it's clear to see that after maybe 2014, the trend of the number of trips is decreasing. So definitely like something has changed here. Probably it was like the Uber and other company came to the city. But did it change the price of the trip? So we see that the number of the trips is less than usual, but let's see what happened with the price of our trip. So we have a total amount. And let's try to convert it to the average. And we see that the average amount of the trip is not decreasing. So like people became less used the New York taxi, but the price of the trip still growing. Let's try to use something more interesting. Also, I had a question regarding the taxi. What is the busiest day during the week? And it's logically to make an assumption that the most popular days are weekdays when the people travel to the office. So let's validate this assumption. So again, we could take a trip time. Convert it to the day number. And again, calculate the number of trips during the everyday. Well, it's interesting to mention that the most popular days are Friday and Saturday, not the weekdays. So it's interesting why. Again, my favorite question, and let's try to identify why. So probably it's related somehow to the during the time of the day. And as a New York City resident at that was time, I made an assumption that the most popular date and times of using New York City taxi, it's a Friday and Saturday evening when the people go to the pub, start to drink, and after that they need to have a taxi to get home. So let's try to validate this assumption. So again, let's try to use the date. And then we here use the daytime. Wrong place. Here we will put hours. And let's try to color with the number of trips. Let's do one more time. Sorry for my drag and drop. Missing. Okay, so we made some kind of heat map where we could see the week of the days, we could see the hour bit during the day, and my assumption was correct that the Friday, Saturday evening, and the Sunday night, this is usually the most popular time for people to take a ride on the New York City taxi. So you see, in a matter of seconds, we could quickly receive the answer directly from the data set. Right now, this table contains 1,300,000,000 records about the taxi rides, and we could receive the answer to our questions in a matter of seconds. So that is why, I love the Tableau. And also, one of the things that I want to show regarding the connector. When Tableau introduced the SDK, they made a very good job in helping other developers to test the connectors they developed. So in SDK, they included almost 1,000 different unit tests. And when you try to change something inside the connector, you could run the unit test for your connector and see the statistics about using the different Tableau features with your connectors. So this is a report that shows the current state of our Tableau connector that has right now 85% of the tests that were passed. When I started to work on this connector, the number of the percentage of the successful test was less than 25. So it's like clear definition why and how the connector improved the situation with the ClickHouse. Support from the Tableau side. And like work is still in progress. So we still like adding additional features inside the connector and sources on the GitHub. So it will be updated from time to time.
I'm going to go ahead and reshare on our side. So let me know if you can see that. You should see Tableau as a BI tool if I got the right screen.
Yeah, it's available.
Great. If you want to do the last couple screens, and then I'll do a quick run through on the remaining tools.
So Tableau, the biggest strength of Tableau, it's an intuitive drag and drop interface, very simple to use. It's very interactive, and people could start to work almost immediately without additional experience. As a possible weakness for me, like the biggest issue, it's a lack of version control. This feature is already available in some of the BI tools, so it's very hard to keep the versioning of your work. And also, as a potential weakness for the different companies, could be a high cost and inflexible pricing from the Tableau.
Yeah, and so thank you, Dima. So we do have additional information here. We'll be posting the slides after the talk, but there's obviously the Tableau documentation, and then we've written docs also that we put on docs.altinity.com, and the links are embedded in the presentation. And then you can get the connector. As Dima says, the project is now open. It's Apache 2.0 licensed. You can go grab it yourself. So I know we're kind of over time. What I'm going to do is just run the remaining slides, which I think will take 5 or 10 minutes, just to contrast this with two other really important BI tools, and then we'll call it a day since we're somewhat over time. So let me just talk about one that everybody on this call probably knows, and that's Grafana. So basically, Grafana it was sort of the open source time series visualization tool. It's really excellent, very easy to install, supports a raft of data sources, particularly around operational data. And in fact, the most important data source it supports is probably Prometheus. It has a number of, as you can see, lots of display plugins, although as we look at other BI tools, it is fewer than we might like. It's very interactive for playing around with time series data. And because that's often what you're looking at when you're doing operational, because it can handle the operational data sources, like reading metrics that have been loaded into Prometheus from various sources, as well combining that with SQL data. It's really good for operational dashboards, and it is open source. So AGPL v3, up till recently, it was Apache 2, but they changed the license 2 or 3 months ago. So basically how this connects. So if you've used Grafana at all, it's pretty easy to get set up with ClickHouse. You're going to just need to load the Vertimedia ClickHouse data source. There's a plugin model that Grafana uses to to present this, to allow new data sources to be added, and you add it at the command line using Grafana CLI. This data source is available, as I'll show you. It was originally written by Roman Kovronenko, who's now at Cloudflare. He very kindly, when he realized he couldn't maintain it anymore, he contacted us at Altinity, and so a couple of years ago we ended up with his help taking over maintenance of the project. It's still under Vertimedia, but we've done the maintenance and like brought it up to date with Grafana 7 and things like that. It's so you can get the code and use it directly, or you can download it from grafana.com. We put every time we do releases, we post new versions up there. I think the last one was in April. So just very quickly, I won't go too deeply into this, but the thing about Grafana is it's really important to understand the organization. And unlike Tableau, which you just saw, it basically, the dashboard connects pretty much straight through to the data source. There are these things called panels. I'll show an example of those in just a minute. But the idea is the panels are configured and each panel does something interesting, does some interesting graphical operation straight on a data source. So there's not like an intervening, as we'll contrast it with other things, there's not like an intervening semantic layer where we're basically doing caching or building a cube. Grafana just doesn't work that way. And in fact, this is a picture of a simple dashboard on airline data. This red highlighted thing is called a panel. When you're in one of the dashboards, if you're an administrator, you can just punch this little button at the top where it shows a graph and a little plus, and that's how you add more panels. It's super easy to configure them. There's a very free-flowing editor that allows you to to add stuff. You can do drop downs. You can use it. Basically, these are selectors. And of course, you can see really nice time series data. I'll skip over this. We have a test endpoint, as does Alexey at Yandex, that gives you data that you can just connect to in the cloud. This is great for doing BI stuff. This is the one that we maintain in the Altinity cloud and some of the data sets. So, to use Grafana, all you do is load the add the ClickHouse as a data source. So if you've got the plugin installed, it just jumps in. You can then define the data set. You just press the URL. One thing about using Grafana is it's important to use it through the server. If you try to use it from the browser itself, you're likely to run into CORS problems. These are things designed to prevent cross-site scripting attacks. You will have difficulty connecting to ClickHouse if you're getting to it from a link that's like from off a page that is hosted somewhere other than where the ClickHouse server is. So this is very straightforward and I won't bore you with it. The interesting thing is the time series graph, because I think this illustrates a big contrast with Tableau. You have this panel editor and basically you dive in, it gives you a data preview, it gives you a bunch of, it gives you a query editor, you can select different kinds of graphs, and then, sort of metadata about the panel. So you just say, hey, where's the data coming from? This is specifically using ClickHouse. There's then some specific information that we're going to look for. It's fairly straightforward if you're familiar with ClickHouse. Once you've used it a couple of times, it's pretty easy to use. This is where the big difference is, which I'm highlighting, is you actually write the queries yourself. Grafana, unlike Tableau, isn't no code or low code, it is code. And it can be pretty gnarly because it uses macros. So you have to get a little bit used to these macros and Grafana, to use time series effectively, you tend to want to use these macros just to make sure that you can then zoom into data and sort of dynamically play around with the time series graphs. So, but it's if you're familiar with SQL and handy with coding, it's not very hard to do. So strengths, it's probably the best on time series support, particularly time series across a bunch of different data sources. It's possible, sort of as you're in the graph to, in these dashboards, to just dynamically move the whole dashboard back and forth in time. If you're looking at operational data, like trying to drill into like, hey, why, what was going on last week when I think my storage started to get screwy. Grafana is just great for that. And particularly because it can also talk to things like Prometheus, which have a lot of useful data. The drill down is very good. You can also dump the data pretty quickly to things like CSV. It has support for alerting. And so overall, it's just generally really good for operational analytics, and that's when we tend to see it. I would say that, just in terms of weaknesses, probably the biggest single weakness or biggest single reason why you might want to reconsider it, aside from the fact that it requires SQL coding skills, is that it doesn't have a caching layer. So if you have a bunch of people running dashboards, when they hit refresh, they all go and hit ClickHouse. So this can cause concurrency problems if you're trying to build like a large multi-tenant system. Grafana might not be the thing you want. So that's Grafana. There's more information, which is in the slides, about how to get it. We like it a lot. It's very easy. Once you're, the editor is super easy to use, particularly for building the dashboards, and it's really possible to be like completely tasteless back-end dweeb, but still produce beautiful dashboards. So, so that's Grafana. I'll finish off with just a quick summary of one of the more interesting things, and then we'll do Q&A down to the bottom of the half hour. That's Superset. And so Apache Superset is kind of a new contender for ClickHouse. It was not, I used it a couple of years ago and wasn't super impressed by it, but Preset is a funded company that is backing it, that's run by Max Beauchemin. He's the guy that wrote it, and it has gotten really, really good. So if you haven't looked at it recently, I definitely recommend checking it out. It is a BI, it's described as a BI platform. This is a slide stolen from one of their dev advocates, Srini Kadamanti. This is a talk we did together, and it works with just about every SQL database you can think of, and there's a huge number of charts. That's, I think, one of the really strong things about it. It has probably at this point at least 40 or 50 different kinds of visualizations that you can use, and they're some of them are super imaginative. So kind of like Grafana, you're typically going to go from the web browser, talk to the Superset server, and then you run through something called SQL Alchemy, because this whole thing's written in Python. And so there's a ClickHouse SQL Alchemy driver, and that turns around and calls the ClickHouse Python, ClickHouse driver, which is just a lower level driver, and then it talks to ClickHouse. The organization of Superset is a little bit more like Tableau, in the sense that there's some abstraction between the physical tables and the underlying tables in the database and the actual dashboards. So you have the connection to the database. You have a couple of kind of data sets, which are basically cubes. In essence, they're able to cache data. Charts attached to that. So, and a physical data set represents a table. A virtual data set is a query, and the charts connect to them, and then you can display them in dashboards. They can be shared across multiple dashboards. That's another thing Grafana doesn't do. So when you create a dashboard, this is a really simple one with just a couple of things, and I'll just show you the steps to create the chart, this geographic chart, because this is kind of requires some complex data that's actually joined across a couple tables to produce. So the steps in Grafana, or excuse me, in Superset, are connect to the database, create the virtual data set, create the chart. So here's how you connect. It's very straightforward. There's a URL format for it. I'm not going to go into the details of this because of the time, but I think it's really important that one thing that's really important about Superset is there are actually two SQL Alchemy drivers, which is incredibly confusing, and they're named almost the same. The first one was developed by Marek Wawruza at Cloudflare. This was the pioneer, but it is not really maintained very much anymore. We don't recommend it. What we instead recommend is the ClickHouse SQL Alchemy driver, which is developed by Konstantin Lebediev, and we're also helping to support that. And we've done a bunch of testing and also did a number of bug fixes that make it work much better with Superset. There were some things that would cause metadata not to be read and stuff like that. I'll skip over the connection strings. They're pretty easy to figure out, but basically when you run this, you know, like when you do this kind of you know, sort of what we call a virtual data set, you build a query first, which creates a list of data that you're then going to build charts off. So there's a SQL editor to do this. And when you get done, when you see that the thing is running, and it's kind of like what Dima showed in Tableau, you can then go ahead and save the query and turn it into a virtual data set. And so I'll skip over the steps, but the end result is that you have this thing which underneath has all, hides all your SQL, and you can now build charts on top of it. And this is an example of, and these charts can be built by anybody. You don't have to write any SQL code. So, I'm picking a geographic chart type called deck.gl, locating my time dimension, giving it the from and to, latitude and longitude, and then a filter, and bang, within literally about 2 minutes, I can have a chart which gives me all the flights originating in SFO and showing everywhere they go in the United States. It's pretty cool. I mean, it's the same. So I feel the same way about it that Dima does about Tableau. It's really very handy. One thing that's interesting is it takes advantage of the fact that ClickHouse does subqueries super efficiently. So that data set, that query that we created, then just turns into a subquery. And what's cool, of course, is that ClickHouse is very good about pushing the filters down into the subquery. So this actually, even though the code looks gnarly, it runs super efficiently. And things like like filter conditions will get passed in and will reduce the data down to the size that you're actually interested in, or to get exactly what you're interested in. So it works super well. This superset, just in a nutshell, is really is more business oriented than Grafana is. So it's in many ways more like Tableau. And the fact that the biggest strength is it opens things up for people who don't write SQL. And it has a bunch of different visualizations, far more than Grafana. I think that the weakness is the maps are a little bit cranky, and it has sort of limited interactive capabilities compared to using something like Grafana. I'm sure that's something that will get better, but when you build the dashboards, they're a little bit more static. But still, it's a really outstanding tool, and the kinds of visualizations that you can do are quite imaginative. So I definitely recommend it. Just more information, we'll post the slides afterwards, but this definitely recommend, these are things that will help you work with it. And one thing I should say about Superset is it's supported by preset, as I mentioned before. So they also have really good documentation on it, and then they run a cloud service, as does Grafana, as a matter of fact. So you can get a lot more support from them. There's many others. If we had more time, we could delve into those, but these are 4 that we hear about. So the Metabase is on my list to look into as soon as I can, but we're very interested. We had some questions about Power BI. I occasionally hear answers about that. Power BI, as far as I know, does not have any sort of public connector to ClickHouse. So I imagine, I haven't tried it, you can probably connect through ODBC, but as Dima experienced or described, that support may not be so great. So that's it. We've run a little bit long. What I'd like to suggest is we'll just take questions for, on things. I'm somewhat constrained by time. I'm going to have to drop off, but I won't kill the meeting. So let's go ahead and somebody just brought up Cube.js. Yes, that's another one we've actually had on this meetup. So definitely one to consider. It isn't a BI tool per se. It's more builds the APIs, and then you as a Java or like a full stack developer bring your favorite graphics package to it and show your stuff. So with that, I'm going to stop the share and we can just go back to video. We did have a question. Let's see. I think that you just answered one, Denise. There was a question, was it, okay, Alexey, you got the question about whether it's possible to use the map data type in dictionaries. So that one was answered. Yeah, so there was any plans to implement gRPC support in ClickHouse SQL Alchemy driver, and as Denise said, the Python driver uses the ClickHouse native TCP protocol. So yeah, we're not going to do gRPC. We're just going to make the native protocol work as well as possible. So any other questions? Please feel free to. I'm going to check the YouTube to see if we've got anything there. Oh, how powerful is the ClickHouse backend for the Tableau demo? Well, I believe it's 16 vCPUs, so it's really, you know, it's running up in Amazon. So it's and Dima, you were going to the public endpoint, correct? If Dima is online, I don't.
Yes, sorry, was on mute.
Yeah, so you were going to the public endpoint, correct? Up to you. I don't know if you missed that. So basically that question from Vitus coming off YouTube was the answer is it isn't a particularly powerful instance, so it probably would by default probably running with 8 threads, max threads equal 8, and it's just really quick. You also have to factor in that there was a pretty good hop to get from where Dima is in Chicago over to where it's running actually in US East 1. So that was added latency on the queries. Still looks pretty good. Let's see, other questions? Feel free to post them. And if somebody wants to talk, give me a yell, we can unmute you. Oh, Larry, I just enabled you, and Leandro, oops, sorry.
Can you hear me?
Yes, yeah, go for it.
I have a question that's hopefully quick regarding the buffer engine. So we have about 1 million rows per second on one server of our cluster, and 16 layers of the buffer table that this is going into, and we're seeing that some data kind of sticks around in the buffer table for much longer than it should. We have some bytes, rows, and seconds configured, and it's flashing regularly. Some data seems to stick around. We can see we have a Grafana dashboard set up on the output of the downstream merge tree tables, and when we do an optimize on the buffer table just to force flash it, that seems to really get everything out, and we see that the graph fixes itself. So we're now running with optimize as a cron job regularly every few minutes or whatever interval is required. But I wonder if this is something that's known or could be easily explained, or if the workaround that we have makes sense.
I don't know if Alexey is here, but Denise, does that sound like something familiar to you?
No, I never heard about it. Maybe Alexey can explain it.
If you can please repeat the question, just reformulate, because I'm here, but I just missed it.
Yeah, of course. So our buffer table, there's one buffer table on a node receiving from a large number of insert clients around the world, and that's all going into one merge tree replica. So that's just a very simple replicated merge tree set up with one buffer table on each node. We're looking at the dashboard that has some aggregations coming out of this merge tree, and some data is missing, going back to sort of 15 seconds, 30 seconds, sometimes a minute, depending on the buffer table settings. And we're seeing that if we force flash buffer table by doing an optimize every couple of minutes or so, the graph fixes itself, as if there was some data still left in the buffer table, and that's now been flushed through. And the normal criteria seem to be going okay. The seconds, the bytes, the rows on the buffer table. but somehow a little bit seems to get left behind in one of the table's layers, because 16 layers configured at the moment.
So I expect that the settings, the thresholds should be enough. So if you just configure maximum time threshold of 1 minute, you don't have to run optimize. But as I see from your question, you observe that it is not true. That some data is not flashed.
That's correct. That's what we're seeing.
Did you try to read the logs related to this buffer table? Because if it cannot flash data, it will just print the reason to the log. And
yeah, we did. No errors in the log.
And you said that if you manually run optimize query, everything is just fixed.
Right, yeah, and the optimized query can take 30 seconds, 60 seconds. That it's obviously pushing some data through.
How many inserts do you do per second?
There is 1 or 2 per second in that relevant metric. I think it's storage flash something. What is one of the metrics which we can see it increment at a rate of about 2 a second.
So you do 1 insert per second, and you write in 1 million per second using 1 insert, and you use buffer table because you want to insert bigger inserts. I don't really understand why do you need buffer table.
Oh no! Sorry, that's the that will be the output of the buffer table. Into the buffer table are lots and lots of little inserts. Yeah, from 1,000 servers around the world. This is a CDN.
What version? What ClickHouse version do you use? I will try to reproduce this here.
Okay, great. I'll stick an issue in GitHub. It's still most recent LTS of 21 branch, I believe.
Okay.
Can't remember the exact
open
number.
an issue. I will try to reproduce it.
There was one bit I noticed in the code, which is where if the insert part of the buffer table cannot find a layer to lock, it will do a try lock. And if it cannot find a layer, it gives up and it says, okay, I won't be trying again. I'll leave it to an insert. But I wonder if another insert doesn't come for a while on the same layer. And hence the optimized works. But let me describe that on the issue. Don't want to take more time of this presentation.
I can only expect that if there are some insert that happens during flashing, it will be just postponed to the next flash, but not past the next flash. So data should not be delayed for more than specified threshold plus the time required for flash.
Okay.
But yeah, still open an issue and we can discuss it.
Yeah. Let me try and find a nice reproducible case and put that in on the issue.
Cool, thank you. Leandro, you had a question. Your hand was raised, so you should be able to talk if you can unmute.
Yeah, thanks. Let me put you in context. We are using Kafka to move data from MySQL to ClickHouse. We have a common problem with updates, okay? To resolve it, we treat the updates as inserts with new version number, which version is the TSMS from the Kafka message. And we use aggregating merge tree with argmax merge and argmax merge and argmax state for the duplicate data, okay? We are pretending to use superset for visualization, but our performance is not the best we could expect. And the usage of RAM goes big and timeout results, okay? We guess if we could make a pipeline with multiple aggregating merge tree one after another, which could deduplicate the data and then aggregate the data for day or for month, for example, to improve the performance.
So the question is that currently you are using multiple independent aggregating merge tree, and you are asking if it will be better to make a sequence of materialized views.
Yes.
Okay. You can make a sequence of materialized views, but it is quite tricky. Denis can explain in more detail.
Yeah, no, it's your approach probably is not very best, is not very good in general. So it's how often, what percent of your data you need to update? Why do you need to update data?
Because we start from a MySQL database, which the data is updated constantly. So we need to represent that information in ClickHouse. It's an approach. I don't. Maybe it's not the best, but is what we have now.
Yeah, I understand. Yeah, but it's the idea of databases like ClickHouse that data should be immutable, and if some attributes is changing frequently, they should be probably represented as a dimensions or as a dictionaries, external dictionaries, for example, in ClickHouse.
But we are not updating data in ClickHouse. We are inserting new data constantly in ClickHouse and they duplicate it with aggregating merge tree using argmax merge. It's a common problem. I think in Altinity you have a post with the last point of activity, I think it calls. You resolve the problem with this approach.
Yeah, that's one way to do it. You can also use replacing merge trees.
Oh, replacing merge tree is another option.
Yeah.
I wanna know if after the replacing merge tree or the version merge tree, we could use another aggregating merge tree for improve the performance of the queries.
No.
After the deduplicate, we want to aggregate that data into months or days or years, for example.
Oh, I think what's going to happen is the aggregates won't get computed. Alexey, if you know, normally with your assumption on aggregates is that, like, if you have layers of data, like where, like an RMT, a replicating merge tree going to aggregating merge tree, I think that sub-aggregation won't work, will it? Because things like averages will end up getting duplicate values in there.
Yeah, materialized view is an insert trigger, and
yeah,
the actually aggregating merge tree, we will not see any changes in the replacing merge tree because actually the engine of the table is which you read in the data into materialized view, it actually doesn't matter. So yeah, it's if you have a lot of data, the best way is to build sort of delta pipeline and send deltas into ClickHouse and don't use argmax functions and use summing merge tree and calculates sums for measures.
Okay.
Yeah, this is yeah. Oh, go ahead.
Yeah, it's a hard question, and in Altinity we spend a lot of time for redesigning your approaches like yours, and yeah, it takes several weeks usually. So it's not very easy to rethink and to build a pipeline which allows to achieve your goals.
Yeah, because you have to really turn everything somehow to make the aggregating merge tree work correctly. You'd have to turn everything somehow into an insert, which doesn't require you to come back later and adjust things in aggregating merge tree. So that's one. Feel free to contact us in the, we're in the Slack channel as well as Telegram. Definitely feel free to contact us and ask more questions. But I agree with Denise. It's a hard problem, and there's not a totally. There's you usually have to step back and kind of rethink what you're doing a little bit to make this work.
Okay, thanks.
Yeah. Recently, they solved similar problem using simple aggregate functions and simple aggregate functions as any last, for example. And maybe it will work for you. You can ask in Slack in public Slack, and we will try to answer.
Okay.
Here's a question that came up from Robin Bartholdson. Can you say something about the upcoming support for transactions? Denise or Alexey, do you want to talk about that?
Robert, what about you? Can you say something about?
Well, I know we're working on it. I haven't tried it out yet, but the idea is so what we're going to do is make our goal is to make inserts atomic, and so
inserts,
that what. Yeah.
So it is about atomic inserts to multiple tables.
Exactly.
And also for consistent snapshots. So you can acquire a snapshot and execute multiple select queries with a single consistent snapshot of all your data.
When's the due date for that to be out in ClickHouse, or is it already?
A prototype will be ready in July, and production support probably in Q3 or Q4.
Yeah. And yeah, and this is something that we get asked about this a lot, because I don't know if the person asking this, whether you're, interested in, for example, making sure that your materialized views don't get out of sync with the sources. It solves exactly that problem, as well as, cases where you have multiple blocks coming in.
But for this scenario, you can try using projections. Projections are consistent already. So you can have multiple representations that are updated atomically.
Great. We had another one, which was here, just a second. It disappeared. 1 second here. Darn it. Oh, we got covered up. Is there any, this is from DJ, is there any approximation on hybrid partitioning for efficient cold data store over the long term to avoid having too many partitions? I have a feeling this means different partition schemes for hot data and cold data. So we do have TTLs for aggregation, which partly address this. Is there a way to do this right now?
So we don't have hybrid partitioning. When you define partition schema, it does not change during time. So you can partition your data by month. It will be just by month. And for recent partitions, you probably will have more data parts. For historical data, data will be probably merged to more large data parts. And if you combine it with storage policies, you can also configure it so historical data will be moved to cold storage and fresh data will appear on hot storage. But it has nothing with hybrid partitioning. Partitioning is just uniform across all data.
It's a question more. It's about idea that probably you can you can move data, for example, from table with daily partitioning to the table with monthly partitioning, and you just need to change sort of partition file in the partition, but it should work actually, because it's just smaller parts and they can be merged. But imagine if we can do with two tables, and after that we can do this inside a single table.
Yeah, I understand this scenario, but I find it quite complicated. What I recommend is don't mess with partitions too much. Don't make too granular partitions. If you have a problem with too many partitions, probably you don't need this granular partition configuration. If you're not sure what partition to choose, just partition by month. It is recommended. Or don't partition at all. It is also possible. It works quite good.
And I think what this specific problem seems to be, this would be an issue if you had a source table that you just kept forever. But in fact, what a lot of people do is they keep their source data for some bounded period of time, like 90 days, and then they TTL it out, like run a TTL delete on it. But then what you do is you have your aggregates, which are much smaller, and those you might keep forever. So I think the other way to think about it is, can you downsample so that the stuff in the long tail just isn't held. I mean, if these are log records and you're keeping them for statutory reasons, you can't do that. But as I say, I think if you can move it to aggregates of some kind, that this problem just goes away.
Yes, it is possible, and it is possible by a feature that is not everyone aware. TTL group by.
Yeah.
So you just define some rules to do data aggregation after some period of time. And these rules can be sophisticated. So you can calculate maximum of one column, sum of another column, average of third, but average is difficult.
Actually, you can use aggregate function VG state. You can use average, yeah. Or you can express average using two columns, sum and count. Yeah, and yeah, I have actually examples in knowledge base in kb.altinity.com if someone interested in TTL go by.
Okay, are there any other questions? I don't see. By the way, hello, Alan. we see friends showing up on YouTube, but I don't see any more questions off YouTube anymore. Here, let me look in the chat. I haven't looked there recently. Do we see any of those? Nope, don't see one. Okay, well, you know what I'm going to say? I think we're done for today. I'd like to thank everybody so much for attending. I hope this was useful. As I say, we've got the next, as I mentioned at the beginning, we've got the next virtual meetup already scheduled for August. I'll publish it shortly. We're looking for talks, so this could be you. And we'll do the in-person meetup for Bay Area folks as soon as we can get a room scheduled. With that, Alexey, thank you so much for presenting the roadmap. Denise, thank you for joining us. Dima, thank you so much for the work on Tableau. It's really great to have you all at the meetup. So with that, thank you, everybody. I bid you good day or good night, as the case may be, and we'll see you at the next meetup.
Thank you.
All right, bye, everybody.